All right, well, as promised, it's time for algebra. I don't even like Eminem, but I allow him in when it's time to bring algebra back. It's really, you just kind of have to let him in then. All right, so the first thing that I want to do is review the two theorems that we've been using so that they're nice and fresh in your head. And of course, I'm going to put some hearts and clouds and stuff in there because why not? We're going to be writing some equations today, and so we don't want the geometry to, we don't want to let the algebra get in the way of the geometry, so I want to make sure the geometry is nice and fresh in our heads, right? So there's a couple things that we know about triangles. When you look at a triangle, there's three angles inside of it, right? It has three what we call interior angles. They're inside the triangle. And in this case, I labeled them with a cloud and a green sun and a moon, a little crescent moon. It's a waning crescent. Okay, there's also an exterior angle. If you got one of these situations where the triangle has a tail, anytime the side of the triangle keeps going and doesn't stop, then it forms another angle out here that we call an exterior angle. We all love a good exterior angle, might as well label with a heart, am I right? Okay. All right, so we know a few things are true. There's some relationships in here that we've been talking about quite a bit. The first one that we talked about a long time ago was that these two angles that are right next to each other are a linear pair, and we know that they have to add to 180 degrees. So in this case, your interior angle and your exterior angle that are right next to each other have to add to 180 degrees. They make a straight line. We know that. We also know that these three interior angles add to 180 degrees. So we know that if we take cloud and sun and moon, they're going to add to 180, right? And again, we've been working with this with numbers. Like if I give you this angle and this angle, you can subtract and get this angle. Now we're going to be looking at these with x's in them, right? But the same thing is still true. I'm going to take whatever this is, whatever this is, whatever this is, add them up and equal to 180. Then we added in the exterior angle theorem, right? And that's this guy. Simplify, looks like a much simpler equation, but look what it is. All this really is like a marriage of these two. Okay? So this one says if you take cloud and sun and moon and add them up, you get 180. This one says if you take cloud and heart and add them up, you get 180. The only difference between these two equations is that in here you have a sun and a moon, and up here that sun and moon has been replaced by a heart, right? It's still cloud, it's still 180. So look, if it's still cloud and it's still 180 and this is the only thing that's different, then these two things must be the same, right? If this is 100, then this must be 80. Therefore, this must be 80 as well. So we know that the heart, the exterior angle, has to be equal to not the guy next to it, but the two other interior angles added up, and that's what this is down here. So we really have two theorems that we're going to be looking at here for the most part. We don't really use this linear pair one that much. The first one is our triangle sum theorem, and that's when you take all three of your interior angles and add them up. So my equation is going to look like interior angle plus interior angle plus interior angle equals 180, right? And we're just going to fill in those blanks with whatever we've got. Right? We also have our exterior angle theorem where we take two interiors, the ones that are on the other side of the triangle, and we add them up and we know that they have to equal the exterior, right? So when we're doing these problems, the first thing we want to identify is what kind of equation do I have? Do I have a triangle sum? Do I have all three angles inside? Because if I do, I'm going to add them up and set them equal to 180. Or do I have an exterior angle in here, in which case I need to make it equal to these guys? There's only really two kind of shells for equations that we're going to be looking at. All right, so let's take a look at them. Okay. Oh, I gotta move my floating head. Okay, up there are our two shell equations, right? Maybe I'm going to add the three interiors and make them equal 180. Maybe I'm going to do interior and interior to equal exterior. Let's find out. Let's take a look at our first triangle. Okay, when you take a look at your first triangle, if my computer will cooperate and not embarrass me. It only took 15 clicks. Okay. All right. When you take a look at this first diagram and you see what's labeled, the first thing I notice about this diagram is that there's no tail on this triangle. There's no exterior angle even here, right? So the fact that this triangle isn't extended on any of the sides probably means we're not going to be using this guy because there's not any exterior angles to be used, right? Now you may notice that these are written outside, but they also have little arrows pointing in. It's just that they didn't think they could fit it in this triangle, so they wrote it on the outside and put an arrow in. But what we're given here is 3 interior angles. Anytime you're given 3 interior angles, the fact that they're all in terms of x means absolutely nothing to me. I'm going to use this shell right here. I'm going to take my interior angles. It's going to be interior angle plus interior, and it's going to equal 180. All I have to do is pluck them out of here. One of them is 5x minus 2. One of them is 9x plus 3. And one of them is 11x minus 21. Doesn't matter at all the order you put them in, because you're just adding, right? Anytime you're adding, it doesn't matter what order you add in. And in the end, we're going to do combining of like terms here anyway. So when you write this, don't let yourself get overwhelmed by how much is here. This is the geometry. I know that if I take the 3 inside angles, they have to add up to 180. So angle plus angle plus angle equals 180. If you're given a number, awesome, put it there. If you're given an x, put it there. If you're given a whole expression like here, put it there. Then we'll deal with the equation itself, right? Because the geometry is done at this point. Now we just have to do a little bit of algebra. Okay, so let's remember DCMCS. We always want to do combining before we start making moves. Okay, you're going to make your life a lot easier if you combine before you move. If you look at the left-hand side of your equation here, I have 3 x terms. I can combine those. And I have 3 number terms. I can combine those. Right? Instead of making 3 moves to move those numbers over here, let's do a combo and use 1 move. So let's add our x terms. 5x plus 9x is 14x plus 11x, 25x, I believe, right? 5 plus 9 plus 11 is 25, right? So this is 25x. Then I'm going to take my number terms and add those up. So minus 2 plus 3, that gets me to negative 1, or positive 1, right? And then minus 21 gets me to negative 20. So I wrote plus, so I'm writing negative 20. You could also just write minus 20. And then over here I still have a 180. Now this isn't a hard equation to solve, right? Once I've done my combinations, I'm left with a 2-step equation, right? Let me go get a different color ink. Green it is. All right, so this is minus 20. I'm going to move it over here with a plus 20. So now I have 25x equals 200. And all I have to do to finish it out is divide. So let's see, how many times is 25 going to 200? How many quarters are in $2? 8. So I know that x has to be equal to 8. Now, if they ask us how big the angles are, we can go figure it out now because I know what x is. So this one right here that was 5x minus 2, that must be 40 minus 2 or 38. That angle has to be 38 degrees. Okay? This has to be 88 minus 21 or 67. And then up here, 8 times 9, 72, right? I'm terrible at arithmetic. 72 plus 3, that one's got to be 75 degrees. So now I know how big they are. All right, so again, don't let the algebra of this bog you down. Okay? We know geometry. We know that those 3 angles are going to add to 180 degrees. Get the equation down, then we'll worry about simplifying and solving it. Okay, I'm going to put another picture up, and I want you to figure out which equation which one you should be using. Okay, which of these equations is right? Okay. Did you say add them up to 180? Did you? You did. Okay. Once again, same thing. I got 3 angles. They're all inside. I'm going to add them up and make them equal 180. So I need to find my pen. There she is. Okay. Interior plus interior plus interior is going to equal 180. Okay, let's go get them. One of them is 4x minus 22. One of them is 10x minus 4. And one of them is x plus 11. Okay. That's the geometry. Geometry. Check. Here comes the rest. Here comes the DCMCS. 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 Okay. I've got some terms to combine. A 4x, a 10x, and a 1x. 4 and 10 is 14 plus another one. I've got 15 x's over here. I have a negative 22. I have a, is that a minus 4? Can't even read my own dang handwriting. A minus 4 and a plus 11. So this is minus 26 plus 11 is going to give me a negative 15, I think, right? 26 minus 1 is 25, minus 10 more is a negative 15. Again, a little bit of combining, and you got yourself a 2-step equation that should be easy to solve. Get a different pen color because, whoa, don't look at that. That's mandatory to have a different pen color. Blue. And all we have to do is move our 15 over. We get 15x is equal to 195. Divide by 15. I'm not even going to go for my calculator. I can do this. 1, 3, 13. Lucky number 13. All right, so x has to be 13. Again, that doesn't mean any of the angles are 13. It means x is 13. If you want to know how big the angles are, we're going to go back here and plug those numbers in. So down here, 13 plus 11 is 24 degrees. So this little baby angle right here must be 24 degrees. 13 times 10 is 130 minus 4. This angle has to be 126. And they're working out. Look, little tiny angle, 24. Big mama angle, 126. It's working out just fine. All right. So let's take a look at the other kind. Since you're probably so sick of hearing me talk by now. It's been 13 minutes. Hang tough. Okay. Whoa. Move your head, Britton. I want you to see the difference here and what just happened in our diagram. First thing you might notice here is we have a tail now, right? I've got this triangle, but it keeps going in this direction, right? It's got a tail. So probably something's going on here. As soon as you see a tail, I want you to start thinking exterior angle, okay? And sure enough, look, one of the angles that they labeled is an exterior angle. So my equation isn't going to look like interior plus interior plus interior anymore. That's not what I have. This is the other guy, right? This is where I have 2 interiors equaling my exterior. And it's important here where they go. In the last one, you're still dealing with 3 angles, but it didn't matter where you put them because you were just adding them up equal to 180. Now you have to make sure that you're adding your interiors and they're going to add up to the exterior. So the exterior is this 18x minus 15. I'm going to, right off the bat, pop him over there on his own side of the equation. Then the other 2 really doesn't matter, right? Because they're both my interiors. Just verify that you don't want the interior that's right next to it. You want the ones on the other side. As Shadow Man would say, you want his friends on the other side. Tiana reference. All right, let's see. 13. I'm going to use that from now until the day I retire when I teach the exterior angle theorem. I got angles on the other side. You know, I got my COVID vaccine today, and I think it's making me a genius. I've had so many great ideas today. All right, look at this equation we got. Interior equals the exterior angle on the other side. Sorry, I'm tone deaf. Okay, 13 and 4 gives me 17. Let's do our combinations here. Minus 11 and plus 1 is minus 10. And then over here I have an 18x minus 15. So one of the things that you might notice about a problem like this is that it's not just leaving you with a two-step equation like before. These ones have the x on both sides. So now we're going to have to make some moves and be a little careful about where we move things, right? So just remember, when you're solving an equation like this, I personally like to put my x's to the left. I like to say letters to the left. And then I put all of my numbers, also known as hashtags, over here on the right. Okay, so I'm not going to move my 17x because he's an actual variable. He's a letter. I'm going to leave him there. This 10, though, I'm going to move. So I'm going to do plus 10. I want it to go to the other side. So I have, these are going to cancel. And I've got 17x over here. Over here I have 18x, and now I have minus 5 when I combine those. Okay, let me recopy this up here. Okay, so now, man, I'm using this forever. This 18x is like, I got friends on the other side. Oh, man. Guys, get your vaccine. It makes you smart. This 18x, pull them over. So now I have 17x minus 18x is just a negative 1x. I'll write the one there that pleases you. And negative 5. So all I have to do is divide out. And I know some of you are like, Britton, I know how to solve an equation. For the love of God, leave me alone. I know. Sorry. I like to go over it anyway. And if you don't already know how to solve an equation, get on that DCMCS. Somewhere in Edpuzzle there's a video of DCMCS. You can feel free to watch it anytime you want. It's free. All right, let's do one more. Slide, baby. All right. You may notice, again, same set here. I've got an exterior angle over here. So I know one thing. I'm going to have an equation that's like something plus something equals this guy, right? 9x minus 8, because I have an exterior angle and he's it. So we don't want the friend right next to him. We want his friends on the other side. We want this guy and this guy. So 7x minus 32 and 5x minus 27. Go. Again, doesn't matter which one you put where. I'm adding them up anyway. All right, so let's use our DCMCS and solve this thing out. Solve. All right. On the left, we can do some combining. I got a 7x and a 5x. Those come together to be a 12x. I've got a negative 32 and a negative 27. You know, it's like I claim to be a genius with my vaccine. They just want to mess with me with arithmetic today. Minus 59. Okay, so we have to move some stuff, right? Let's take this negative 59. I want my letters to the left. Negative 59 has got to go. Add the 59 to both sides. You know what? Okay. All right, so over here it's canceled. I've got 12x over here, 9x, and let's see, 59 and a minus 8. That'd be 51, right? Ta-da. All right. 9x. Go find your girl over there. 12x. She's waiting for you. All right, 12x minus 9x, 3x, 51. Arithmetic-wise, I have a bad feeling about this, but I think it's going to work out just fine. I need to take 51 and divide it by 3, right? If you have 3x equals 51, I need 51/3. And I know what you're thinking. That's going to be a decimal, Britain. I beg to differ. 3 goes into 5 one time. Baby. 17 exactly. Sweet. All right. So, 2 things. Number 1, at the end of this video, put any questions that you have on writing equations or DCMCSing to solve those equations. I will read them and I will address them in class tomorrow. I would also like you to go to Schoology. There is an assignment in there called Triangle Sum and Exterior Angles with Algebra. Go do that, please. Thank you. I will see you tomorrow. Have a lovely day.